Hey, this is Mr. Beckstrom, and I want to take a look at number 4 from section 3.8. This is on implicit differentiation. It says find the equations of the vertical and horizontal tangent lines of the following ellipse. Hopefully you remember something from calculus trigonometry about um, graphing the ellipse. I don't know if you remember, but we can take the y's and group them, and then take the x's and group them, and we can complete the square, and then we can find the major axis and the minor axis, and we can graph this ellipse. So I'll let you go through that part. But if you want to, what you can do right now is you can go to something like a Desmos here, and you can type in that equation, and you can graph it like this, just to kind of get an idea of what that's going to look like. So the vertical axis is going to be the major axis, the horizontal axis will be the minor axis, and this thing is being pulled vertically. Looks like the center is going to be at 2, -5 here. And so this is what it looks like. And what it's asking us is to find the equations of the vertical and the horizontal tangent lines of this ellipse. So looking at this graph, we're going to find the equations of the vertical tangent lines, so that's going to be probably here and here, and the horizontal tangent lines right here and here. Now, just looking at this, I can probably guess what those are going to be, right? The horizontal is going to be y is equal to -1 here, y is equal to -9, and the vertical are going to be what? X is equal to 1, and x is equal to 3. But we have to have some mathematical way to derive that. So let's go ahead and do that. So let's first use implicit differentiation in order to find the derivative with respect to y. So we're going to go through and do that. So remember, whenever we take the derivative of the y, we're going to put a y prime there, multiply by y prime. So derivative of 16x squared is going to be 32x. Using the power rule, plus derivative of y squared is going to be 2y, but we took the derivative of y, so I have to multiply it by a y prime. And then -64x is just going to be -64. And y is just going to be +10, but I took the derivative of y, so I have to multiply that by y prime. Plus 73 is just going to be +0, and then equals the derivative of 0 is also just 0. So this is what it looks like. So let's group the y prime terms on the left and everything else on the right. So we're going to have, and then I'm going to factor out the y prime as well. So I should have a y prime, then I have a 2y plus 10, like this. Oops, that's kind of big. 0 plus 10 on the left, and then on the right, I'm going to bring over that 32x, so that's a minus 32x. And I'll also bring over that 64, so that's a plus 64. And then finally, I'm going to divide both sides by the 2y plus 10. So I should get that y prime, or you can write that as dy over dx is equal to -32x plus 64 all over 2y plus 10. So what does this give us? This gives us the formula for the slope of the tangent line at any given point. And notice that on the top here, we have x's, and on the bottom that we have y's. So the x's here, it's whenever the top is equal to 0, we're going to have a derivative of 0 that's going to give us a horizontal tangent line. And so if we set that top equal to 0, so if we set -32x plus 64 equal to 0, that function will be equal to 0, right? The derivative will be equal to 0. And so x is equal to, what is that going to be? That's x is equal to 2, right? And so with the bottom there, we set that equal to 0. 2y plus 10 is equal to 0. We'll get that y is equal to -5, right? So we get an undefined slope at -5, and we get a slope of 0 at x is equal to 2. So now it's going to be about plugging these in to find out where we have, so that x equals 2 will give us our horizontal slopes. That's where it's equal to the tangent line has a slope of 0, and the y is equal to -5 is going to tell us where we have undefined slopes. That's going to tell us where we have vertical tangent line. All right, so let's do the x equals 2 first. So I'm just going to plug that to my original function there. So that's going to be what? 16 times x squared, 2 squared, which is 4, plus y squared minus 64 times 2 is 128. 128 plus 10y plus 10y plus 73 plus 73 is equal to 0. So this becomes a quadratic, y squared plus 10y. Alright, and this is 64, -128. That's going to be, what is that? -64, and 73 is plus 9. Plus 9 is equal to 0. So that's going to give us a y plus 1 and a y plus 9 is equal to 0. And sure enough, that gives us that y is equal to 1 and -9. Let's see if that corresponds with what we had in our graph before. So y is equal to -1 and -9. Looks good. Alright, now let's do the same thing. Alright, so now we're substituting the y is equal to -5. So we're going to get 16x squared plus -5 squared is 25 minus 64x plus, or actually that's going to be what, a minus 50. Let me substitute in that -5 there. Plus 73 plus 73 is equal to 0. So doing this, I'm going to get 16x squared minus 64x, and I'm going to have a plus 25, a minus 50, so that's minus 25, and a plus 73. So 73 minus 25 is 48, so plus 48 is equal to 0. So plus 16x squared, that's going to be minus 4x and plus 3 equal to 0. So we're going to get x minus 1 and x minus 3. So that's going to give us x is equal to 1 and 3. And once again, let's see if that matches up. Peter just froze up a little. There we go. Okay. And that does match up. And my computer just started doing some funky stuff, but that is correct. So if you have any questions, let me know, and have a good rest of your week. Thanks.